Hi everyone, today we're talking about soilless media. Normally in our lab we would mix up different proportions of peat moss, perlite, vermiculite, and then do some water pour-throughs with fertilizer to see what is happening, how many nutrients are being held up in the soil and all that sort of thing. Um, can't obviously do that, but this lesson should bring you up to speed with what you need to know. So let's get started. What's the definition of soilless media, right? So it's media means a substrate or like a soil-like structure that roots can grow into, but it is not from a mineral soil, right? So this is not mineral. So there's no real mineral-based soil in a soilless media. It can be organic. That's why it's sort of tricky trying to define this. Often they are organic and is in plant material, so bark, husks, peat moss, coconut husks, that kind of thing. So we're going to look at the different types of substrates. But they're not normally found in soil per se, not in significant quantities, right? So it is mostly, soilless media is mostly for container grown crops. Now, your typical container grown crops might be your poinsettia crop for Christmas, stuff like that. But don't forget there are others like nursery grown crops, trees and shrubs, perennials, that sort of thing. Um, But typically, this is nursery and greenhouse production we're talking about here. Uh, Natural soil is not suited for container growing. Now, someone I'm sure is asking this question, why can't I just go to my garden and dig up some soil and put it in a pot? Some plants can handle that, but typically, naturally formed soil requires a little extra drainage. And if you think about it, you walk into a garden and you put a plant in the middle of your garden and then you water it, all right? That water can move basically limitlessly to the left and right and down. It's not bounded by a plastic barrier like a pot. And so there's a lot more flexibility with what can happen with natural soil in context, or what we could say in situ. So it's really not fair to say that natural soil is not suitable. It's just that in the context of a plastic pot, it holds the moisture in too much. And typically naturally formed soil in a pot is not suitable for a lot of plants, and you get root rot. It's very difficult to feed. It just doesn't work well. So it doesn't mean you can't do it. You'd have to amend it by improving it with some things that we'll talk about later in the lesson. If you really are determined to do this, it can be done. And obviously some organic production facilities actually have to rely on these sorts of things to make it work. Um, So yeah, natural soil in a pot doesn't work so well. So we're looking at both organic supplements and synthetic media in this lesson. So what is an ideal soilless media? What are the characteristics? So uniformity, we like that because when we're trying to scale things up for production, we need things to be predictable. When we're filling pots, we want to know that what's going in the pots is the same across all the pots so that our plants will grow predictably and we can sell them consistently. We also want them to be pest free, right? We don't want diseases or seeds, so they have to be clean. And then there's the growing attributes, right? We want it well drained, obviously, just like I was just saying, because we're growing in pots. We need to be able to make sure there's enough oxygen, and that when we water, it will drain freely out. So that gives us, the grower, more control over what's happening inside that pot. Um, we do want it to be able to retain some moisture though, right? Not just, a pot full of gravel where you water it and then it's gone. That's not going to work so well. And then of course we want to make sure there's no residual salts. For example, something like coir, we'll talk about later. You can have salt issues, same with bark-based media. So we have to be careful that we're on top of that. Um, some farms actually build their own soil, right? So they buy in the different components and they add them in an assembly line fashion, and then they can customize it to the crop that they're planting for that day. That's obviously large, sophisticated facilities that are able to do that. Um, but it does happen. Here's another picture of a farm with a substrate mixing line, so they can customize their blends. And there's also some savings to be had if you are big enough to warrant that. Um, so formulating a mix, we're going to look at things like what do we want? We want good drainage, good aeration, easily wetted, so wetting agents, appropriate water holding capacity, stable, flow easily, uh, that kind of thing. Can it go into a machine? Can we convey it? Can we dispense it? And non-toxic seems like a given, but you know, hey, for sure, why not put that in there? Chemical properties. We want some decent cation exchange capacity, right? That's so that the soil holds some nutrients and also has pH buffering ability. Short-term crops, we don't care so much about cation exchange, whereas longer-term ones, we are definitely looking for cation exchange. So I think long-term would be, for example, perennial crops. Some perennial crops are at the farm for 2 years before they're sold. So that soil has to be able to function and maintain nutrients for quite some time and not biodegrade significantly. We want a pH that's ideal. You know, we don't want a media where we're constantly struggling to bring the pH down to where the plants are happy. Some nutrients are pre-charged into soil, so to give you a bit of a starter when you first plant, that's optional. And then, of course, pasteurizing is to make sure that it's sterile. There's no spores from fungal disease or bacteria that could cause problems. So what are the different components? Peat moss, perlite, vermiculite, sand, bark, coir, and rock wool. We're going to go through this list. Peat moss, typically harvested from bogs. Canada has some of the largest peat moss supplies in the world. Quebec, New Brunswick, northern Manitoba and Saskatchewan, although they're not really used much. It's mostly New Brunswick that has our biggest peat bogs. And so they go out and they shave the top off, and then they just skim the surface every year. And so they skim these vast areas, and they take the top off, and the moss continues to reproduce below. It's a self-regulated industry. The idea is that the bogs are abandoned periodically to regenerate, so they sort of rotate through the bogs. I'm not sure how well they do that. In typical Canadian fashion, we just let the industry self-regulate, so don't know what that means. But peat moss definitely is the most popular for lots of reasons. It's got the correct pH, has organic matter which will support life like beneficial fungi and bacteria, has decent cation exchange capacity, and has excellent water holding capacity. So those are all properties we really like. Here's close-ups. We briefly talked about this earlier on in the term, but I thought I'd bring the picture back. You can see how the individual strands of peat moss are made up of a sponge-like structure. And my best analogy is shoelaces in a bowl, right? So air and water can move between the shoelaces, but the shoelaces also hold on to moisture in amongst themselves. So excellent properties as far as plants are concerned. Looking at coir, coir is actually made from the husk of coconut, the outer part here. They knock it off. It's usually a waste product. You might see the coconut in the grocery store, but the husk is the exterior. It's hand collected, shredded, and washed with machines. Is it sustainable? I suppose, although typically it's a waste product, but the last thing we want to see is people purposely growing coconuts just for the husk, because that's a huge waste of land for how few you get. So I think we have to keep an eye on this industry, that as it grows, it doesn't turn into something that is that has economic impacts. You know, where instead of food being produced, we're producing coir. That's not always a best scenario. Typically, high salt levels are an issue, especially potassium. So farms have to pay attention to the salinity of their coir. As far as a growing mix, it has excellent aeration and water holding capacity. Many studies have been done that show that plants root better in coir than they do in peat moss. On the right is some pictures showing some tropicals grown in peat moss on one side on the left, and coir on the right. And there's definitely better root formation in the coir. Coir also seems to stand up for longer term crops than peat moss. It just lasts longer, so it's maybe better suited to longer term crops. In the hydroponic sector, a lot of farms have actually been switching to coir-based bags. These are plastic bags that are filled with coir, and nutrients are dripped into the bag with drippers, and then the plants grow up out of the bag. Uh, we'll talk a little bit later about rock wool. It's coming up soon, and then that might help explain why some of them have switched to this. The rooting's definitely beneficial. You can also use some organic ingredients, which is also helpful. Um, and it has decent water holding capacity, but has enough drainage that you can give shots multiple times during the day. So it does work fairly well, but the verdict is still out. A lot of farms in recent years have kind of gone back to rock wool, so it's about 50-50 in the industry. Um, I think there was more root disease in the rock wool. And hydroponics is kind of an extreme root environment, so it's hard to say. Peppers are pretty tough, so a lot of them still grow in coir, but tomatoes not so much. Other alternative organic soilless media would be shredded wood. There's a company called Growbark. This is a link here. You can follow that if you want to on the other video, on the other PowerPoint in this folder that has no audio. And check out them. But basically, they shred wood and bark into a fine mulch, and they compost it for a period of time, and then it's sold as soilless media. Has pretty decent water holding capacity. In fact, between peat moss and coir, shredded wood products have the highest water holding capacity. So you've got to be careful with crops that like good drainage in the root zone. It may or may not be suitable. The last 2 years we've grown poinsettias in Growbark media, and they've done fairly well. But we do have to be very careful because that's an example of a fine fibrous root that does not like wet root zones. And we had some minor issues, but nothing crazy. So it can be done, but you definitely water far less frequently. Salt levels can be an issue. The way trees grow, they deposit potassium in particular into their bark, and so that can be an issue. It's a nutrient, but excess can be an issue, so it's important to keep an eye on that. So yeah, some growers do pour through EC checks before they plant their crops. I think quite a few growers have been burnt by this type of media where their crops suffered extensive damage. High salt levels will kill your roots, right, which obviously is not good for your crop. When we talk about soilless mixes, there's always things we add to those mixes to improve them, right? So here's the list of vermiculite, perlite, sand, and wetting agents. Vermiculite is mined from the ground. This is an open pit mine in South Africa, but they're mined in different places. In Canada, we have a couple in Quebec. These are some chunks. You can see their size relative to paperclip. Now, they come in different sizes, but it is a sandwich-like structure, like an accordion. A lot like clay. We know those pictures, but bigger. Technically, it's expanded mica. So it's a rock, mica rock, that you bake at high temperature, and it forms these layers. They sort of expand into like a whole sheet of pieces of paper. It's very lightweight. And it improves water holding capacity and also adds magnesium and potassium to the soil. So there's some nutrients coming out of it as well. But the principal reason is water holding capacity and cation exchange capacity. So remember that. That's the ability to hold on to nutrients. So in situations where you want to have increased water holding capacity, so plants that are susceptible to drying out or conditions, so maybe like a young seedling has a very small volume of soil, we might add vermiculite to improve water holding capacity. Vermiculite does not affect the pH of the soil. This is a close-up picture here. You can see the shape. It looks a lot like clay, but this is not as magnified, right? So these are fairly large. Looking at this tray here, you can see the little chunks of vermiculite that have been sprinkled on top. And here's someone sprinkling the vermiculite over the soil. A lot of seeds don't want to see light in order to germinate, and they also want to keep the moisture in, because once you seed them, you don't really want to have to go back and water too many times because it disturbs the soil and disrupts the seed. So by pre-moistening your peat moss, seeding, covering over with vermiculite, and then dribbling water gently over the whole tray, you can leave that tray for quite a while and it will germinate just fine. Perlite, that's another ingredient. You've seen these white chunks that use in peat moss mixes. That's perlite. It's made from a rock which is known as obsidian, which has lots of moisture in it. And when they bake it, it kind of melts and the water pops like popcorn and opens the rock up into these crumbly white popcorn bits. This is an open pit mine in Turkey. There are mines all over North America. There's 1, 2, 3, 4, 5, 6 mines in Canada and many in the States. Distribution, production, I think the green triangles are mines in the States. But anyways, there's an ample supply of this stuff. This is a zoom in on what happens when the rock is baked. Just like popcorn, you get all these like cracked open crevices inside these crumbly white structures. What does it do to soil? Well, it doesn't affect the pH. It has low water holding capacity. So this basically, we're improving drainage significantly by adding these. And we also prevent compaction. Those are the two key things that perlite does. So it improves the drainage, right, and prevents compaction. If you got to think, if you're watering pots over and over again for the lifetime of the crop, the soil starts to compact and you lose your porosity and the roots get less and less oxygen as they grow. This happens with crops that are grown in soil for more than 4 months. So perlite is a really important ingredient for that. You look at your common houseplant, how many times has it been watered in the life that you've had it, and that soil is compacted. Typically the roots just grow around the outside then where there's oxygen. And at that point really it's time to transplant. So perlite improves aeration and drainage. The two are kind of related. Has a tiny bit of cation exchange capacity, but nothing significant. Yeah. Sand. Here's a picture of propagating sand. Sand is fairly heavy, but it's inexpensive. It has zero moisture retention. Think of them as just giant quartz blocks that are being mixed into your peat moss that also improve drainage and aeration. But it's heavy, and businesses choose cost, right? Perlite is light. It doesn't settle. It stays blended in the peat moss when they mix it and bag it, whereas sand, as you bounce around, the sand will always settle to the bottom. So it's hard to maintain consistent mixing when they put it into bags. Some companies or some farms will manually add sand to their mixes to improve their drainage. But typically it's found in propagation mixes. Why? Because in propagation we're misting frequently, right? So lots of water, and we want to make sure we don't drown our cuttings. So adding sand or lots of perlite will improve the drainage so that we don't get root rot in our newly formed roots. So that's kind of a precarious time for cuttings. Rock wool. This is a synthetic media. So there's no organic component. There's no peat moss. There's no coir. There's nothing. This is just basically rock that is melted and spun like cotton candy. So it's spun out, collected. This is actually cotton candy, but this is the real stuff. Fancy machines that spit out fine fibers that are glass-like. And they mat out into these structures that we can cut with a saw and shape and grow plants in. It is most popular with hydroponics where you're frequently irrigating, so anywhere from 5, 10, 15, 20 times a day. There's no water holding capacity, very little. The water just goes in and comes out the bottom, which gives the grower maximum control of what's happening in the root zone. These are not biodegradable though, right? That's an issue. Tomatoes, cucumbers, a lot of hydroponics is grown in rock wool, primarily for the fact that you can control exactly what's happening in the root zone. They are recycled into bricks, paving stones, and things like that. They collected, melted down, and mixed with binder and sand to make paving stones. So they can be recycled, but it's not organic. The other thing is you can't use organic fertilizers in this type of media because it won't support organic life. These are for sterile growing conditions, principally. So soilless media, we've got peat moss, bark or wood fiber, coir, rock wool. We've talked about perlite, vermiculite, and sand as additives. Um, how do you choose a mix, right? What do you do? So it depends on the crop you're growing, right? I've mentioned a few times the duration or the length of the crop. So nursery crops, they're looking at soil mixes that need to stand up to the test of time. Um, Cost is always a factor. Um, Going back to the length of the crop, so you want something that's not going to break down too quickly or compact over time, right? So if you're irrigating over a couple of years, you need to make sure that it's not changing its porosity. So perlite is obviously an important ingredient. They may go with sand and mix it themselves if it's cost effective. Um, they may go with more of a coir because the coir fiber will not break down as fast as peat moss. Um, Cost is always a factor, looking at the cheapest scenario. So that often is variable in the industry. Some years peat moss is cheaper than coir, and sometimes it's reverse. Uh, and sometimes wood fiber is even cheaper. So depending on what you can get away with. What does your plant's need for air? Do you have a plant that's particularly sensitive to really wet root zone? So then you need to look at the porosity properties of your media. Um, Do you need water holding capacity? How extensive will it be? Are you doing propagating? Are you not? You want to pay attention to that. Do you need to support biological life? I mentioned this in another slide, right? So are you going to use biological fertilizer, so organic fertilizer that needs bacteria and protozoas to survive in the media? You may want to work more with a wood fiber or a coir media. Peat moss works too, but you know, something that's going to support biological life. So rock wool is clearly not going to do that. Fertility. Do you have cation exchange capacity? Is that important to you? Typically, nursery crops don't get fed very often, so they need to be able to hold on to nutrients fairly well. So it's important to them. Whereas in greenhouse-grown ornamental crops, the growers want to control the nutrients a little more, so they're not looking for huge amounts of cation exchange capacity. Whereas if you're growing organic, you want to hold on to all the nutrients you've got because they're limiting and it takes time for the organisms to mineralize them. So having cation exchange capacity sort of helps make sure that that doesn't slip away. And oftentimes adding a small amount of compost will help improve that as well. So other factors for choosing a mix: uniformity, ease of handling, versatility, sterility, and convenience. Um, all kind of convenient stuff or straightforward, I mean. But this last slide is showing an example of strawberries being grown in different types of mixes of media and seeing how successful they are. And it's quite a striking picture because you can see there's a lot of difference between them all. Like, for example, 50% vermiculite and 50% perlite is horrible. The plant's barely grown. Now that's consistent across both these varieties. Granulated rock wool has done fairly well. That's just chunks of rock wool. 100% cocoa, not so. That's your coir. That's not great. But if you add perlite, right, so that prevents compaction, improves drainage, all of a sudden the strawberries are doing well. And then 70% coir and only 30% perlite seem to do quite well as well. So it's never always straightforward. I'm going to make another slide to talk about wetting agents, and I'll be right back. Okay, so it's going to take a few minutes to talk about wetting agents since we're finishing up soilless media. Soilless media like peat moss, coir, wood fiber, if they are allowed to dry, they do not wet. So they're naturally what we call hydrophobic, so they resist water. The best example I have is if you go for a holiday and you come back and you got to water all your houseplants and you add your water and all of a sudden the soil ball floats up or the water goes around the side and drains out the bottom. What's happened here is that the soil has become hydrophobic. In the horticultural industry, we add wetting agents to our media to help them attract water. So by adding soaps, detergents, what that does is it changes the surface tension of the surface of the coir or peat moss or wood fiber so that it's less hydrophobic, right? So there's this less hydrophobic. So hydrophobicity is what we say, what describes these surfaces naturally. So we want water to be able to stick, not bead off of it, right? And one of the bonuses is that by using wetting agents, we can save save on water use. So there's less frequent irrigation required. Now, if you go and you buy peat moss or coir or whatever commercially, they add wetting agents in the factory. And in time, that washes away, right? So every time you irrigate your crop, some of that is lost. And typically, after about 3 months of use, depending on how often you irrigate, that wetting agent is completely gone, which is fine if you never let the soil dry out. But of course, if you do let it dry out, then the surface is going to become hydrophobic, and then you'll have a difficult time re-wetting it. The best example is at this time of the year is hanging baskets. So you go camping for the weekend, you come back, you want to water your hanging baskets, and you pour some in the top, and right away it's pouring out the bottom. If you actually take the root ball out of the pot and take a closer look, you'd see that the root ball is actually not really getting wet. It may look wet on the outside, but if you broke it open and looked, it would be dry as a bone. So commercially, wetting agents are added to the irrigation water periodically. And in the bedding plant industry, often there's one shot of wetting agent added prior to shipping. And that does a couple of things, right? It improves customer satisfaction, right? So the soil will not become hydrophobic as easily. So if it does dry out, they can rewater it better. It also means that less water is required at the garden center. So if they ship their plants and they don't get watered as frequently as they'd like, there's a better chance the plants won't completely wilt and die as quickly. But these are basically, a kind of detergent or what we call surfactant. I do have a Derrick solution to this. If you want to try to fix your hanging baskets, if you've had trouble getting them to water, you put 1 or 2 drops of dish soap in your watering can. That will help improve the properties of the water so that it will penetrate the peat moss and wet it. Now, don't put a lot in or it's going to damage the membranes on your roots and you'll end up with some root disease, but just a couple of drops, right? We're not talking foam pouring out your watering can here. But, that's a helpful way to improve the wetting, reducing the hydrophobicity of your media and your hanging baskets. All right. I'll post some review questions and stuff after this lesson. Okay? Bye.